Indicators are substances which change color depending on their environment. Cabbage juice is an acid-base indicator which, when placed in colorless solutions, experiences a color change depending on the pH of the solution. In Part A, I add cabbage juice to solutions which have approximate pH of 1 up to 13. You will see that each solution takes on a color different from all the others. Record the color you see for each solution to the best of your ability. We will use this information again in Part B. Here you see a picture of a test tube rack containing solutions of various different pHs. You'll notice that all of the test tubes are labeled with their pH. Here you see that all of the solutions are colorless before cabbage juice is added. I am now going to add cabbage juice to each one of these. Specifically, I will add 2 milliliters to each solution. Here I am, adding the cabbage juice to the solution with pH 1. You can clearly see that a color change is taking place. I swirl the test tube and then set it back in the test tube rack. Here are all of the test tubes after the cabbage juice indicator has been added to each. Pause the video if you need to record each of these colors. Notice on the report sheet that the row for pH 7 is below all the other pH values. In Part B of this experiment, I will be adding cabbage juice to many different solutions, some of them being household solutions, such as vinegar or ammonia, as well as to other mixtures, like some various soaps and shampoos, to determine their pH. Now, this is a great method for determining pH of clear and colorless solutions, much like the reference solutions you saw in Part A. Unfortunately, it is not always a satisfying way of determining pH for solutions which have colors, which can conflict with the color provided by the cabbage juice, or with substances which are white, like, say, soap or shampoo. So all that I ask here is that you do your best in determining the approximate pH using the color of the solution that you see. It's not expected that you be completely perfect. In the next part of the experiment, we're going to use a more accurate method, specifically a pH meter, to figure out what the pH is for each of these solutions. So on the report sheets, you'll want to fill in your observations in the first 2 columns of the table that you see on page 139 under Part B. The first column asking you for a color description, the second column asking you for a approximate pH. As I said before, some of those results can be a little bit unclear, so just do your best to estimate a pH. We are not going to do any additional items beyond the ones specifically listed on page 139 to test for pH, so you may draw a line through the table on the very top of page 140, which is labeled Other Items. For this part of the experiment, I will not provide much narration. It's mostly going to be your responsibility to simply look at the colors of the solutions and determine their pH. What you will see me do is take each solution or mixture, add in some cabbage juice, swirl, and then I will hold up the results of that test next to the reference test tube rack, and I will just kind of walk that back and forth in front of the different test tubes so that you can find the best color match possible and assign your pH based on that.